All right, guys, up here. Guys, last lesson in polars. Here we go. Focus, guys. Come on. Here we go. All right, we are graphing spirals and, oh, the S got left out of it. It's lemniscates. There should be an S. Lemniscates. There's, yeah. There should be an S here. No, it's lemniscates. Rewrite it.
We throw out lemniscates.
No.
I forgot.
So did I. There's an S in there. I don't know what happened. This first one is a spiral, and so we're actually just going to make a table so you can see how it works.
Is it like the tangent or something?
Nope, that was not that. I'll show you what happens when we plot. That was not that. That makes perfect sense, right? Okay, so when theta is 0, what is R? Good work. Off to a brilliant start today, guys. Okay, the other ones we're going to think our way back to them. We're going to do pi over 4, pi over 2. That is not a 2. There we go. 3 pi over 4, pi, keep going, 3 pi over 2 and 2 pi. Okay, I'm listing all of these out because we have to think through approximate decimals. What are these? So let's start with pi because we're probably most comfortable with pi. What is pi as a decimal? 3.14. Okay. 3.14. Okay. So if I did, let's go to pi over 2 next. So if pi is 3.14, what is pi over 2? 1.57. Guys, I'm even just going to round to 1.6. Okay. Oh, it's getting crazy here. Yes. So what is 0.4, or I'm sorry, pi over 4 going to be? 0.8. Yeah.
Wait, Mitchell, are you okay if you round like this?
Yes. For spirals, we're approximating. Like, think about trying to plot that. 1.57 versus 1.6 when you're plotting it on this graph. Is that going to be any different? I mean, I hope not. I don't think it should be drastically different. What do we want to put for 3 pi over 4 then? 2.4. We're good with that. What would 3 pi over 2 be? Yeah, because it's like, well, 4.74-ish, 4.8 is fine. What about 2 pi? 6.1, sorry, 6.28, right? Okay. Close enough. 6.3 is great. So let's plot these. So 0, 0's in the middle.
Is this one a spiral?
Yes. Pi over 4, so the 45 degrees, I'm going to put 0.8. So almost out there. Pi over 2, so if at 90, I do 1.6, more than 1.5. 3 pi over 4 is 2.4.
Will this go off or
Yes, slightly. Pi is 3.14. Down at 3 pi over 2, I've got 4.8-ish. And then 2 pi, we're somewhere off over here. If I connect these, do you see?
6.3 is off.
Yep.
Whoa.
You see how it's a spiral that like just keeps going? I did a bad job over here, but you get the idea. Guys, we don't do much with spirals, okay? Like, there's what a spiral is. I might put a negative in there, something like that. We can shift it, but don't expect like a test full of spirals, okay? This is not. Okay, that is a spiral. So if you see r equals theta, you know you've got a spiral.
How like these in the real world?
That, not much. Which is why it's not a big Okay, guys. I want you to try to graph these two spirals. Notice this one goes 0 to pi, both of them 0 to pi. The negative 0.51 is small, okay? Like you're going to have a teeny tiny little spiral. Left. I think so.
Where's my on here?
You forgot your glasses. No, different thing.
Wait, no, 0 to 5. Okay, so then we gotta keep going. Wait, I do 1. Yeah. 6 point.
Have you done
Oh my god. It doesn't matter. Negative 0.4.
All right, well, you got your graphs graphed?
How far from the negative?
It's the same off the graph as the last one.
Really?
Oh, we're only going.
So we're only going to pi. Your last point of pi should be like 6.28.
Yeah.
Okay.
I will be using computer, right?
Yes. Yeah, guys, you can use fewer points for these graphs. You don't have to graph it's quite as many as we did for the first one, okay? Because we're only going to pi.
Probably not.
I don't get this.
I don't think I did this right.
No. Right? There's a negative 0.8.
Mine is already open.
That's going to be a small spot. It's delayed. The second graph is like a really small spot already. Okay.
Nope.
So then, yeah. Whatever. 1.2. So then it's gonna.
I mean, kind of. A shy spiral, I like that.
Whoa. 1.6.
I got a 0 on it.
Yeah, what's up?
Negative theta.
The theta just is what you're plugging in, and then you're taking that times negative.
I don't think I negative. So you
So you go left.
if it's theta, I squared here.
You'll start with the theta first. You do the R first. And you're
I
plotting,
said in the article, blah, blah, blah.
and then travel
That
higher.
doesn't count as normal.
So 225. Is that all?
Is it what?
R first.
Always, yeah. All right, guys. R equals 2 theta. Are we okay with that one? Yes? It kind of just doubles the values that you looked at on the last one, right? How are you on the R equals negative 0.5 theta? Are we okay with plotting negatives? Remember, you do the R first, so you're going to go left for these and then travel the distance. They're like all really small in here. That's like all you get out of it, really.
Great.
You what? You can absolutely make a table. I was just kind of using the same table as before, but cutting it in half. So okay. So we know that's like 1.6 regular, right? Taking that times negative 0.5 is going to give you negative 0.8. So that's...
Oh, I was using the 2 pi graph.
Okay, okay. All right, any other questions before we keep going? All right, guys, turn the page. Let's talk about it. Kind of. That's what we're doing. All right, guys, this is a lemniscate. Lemniscate. It is not bad. I will show you. I promise. We're not actually going to use the table. Hey, guys, I cannot teach over you guys. This is way too much. Okay, you got to rein it in. We only have like half an hour left in here. A little over half an hour. It's a quick day. But I can't just yell over you and hope you're learning what I'm teaching. Okay, so pay attention. Do you guys see how this looks different than anything we've graphed before? What tells you, yeah, if you see R squared, you're like, ooh, that's something to note. This is a lemniscate. Kind of. Lemniscates.
That sounds like some kind of like mollusk.
Is that French?
A little bit. All right, guys. We're going to start. I know there's a 4 in front of this, but kind of like you did with roses, we're going to look at the sine of 2 theta and think about where sine has the maximum value of 1. So where does that happen? Pi over 2. So 2 theta equals pi over 2.
Are we supposed to write this in the table?
Yeah, I'm not going to actually use the table part of it. You could plot points. That's definitely one way to do it. But I'm going to show you what I think is an easier way. All right, so our theta is pi over 4. That means, like, thinking back to roses, you had, like, the end of a petal, the maximum length of a petal at that angle. So we're going to have that again. Guesses on what the length of these sort of petal-shaped things are? 4. Yes, because it's r squared equals 16. So you have 4. You technically have positive and negative 4, right? So I'd have 4 at 45 degrees here. 1, 2, 3, 4. And then if I do negative 4 and also go 45 degrees,
This
I'm
is
there.
the pole, right? Or no?
Yes. Yeah. Oh, yeah. It will definitely go through the pole. Okay. What this graph looks like. We know sine, when we graph it, it starts at 0. So this sort of weird, like, propeller-shaped looking. And they can be even a little more roundy than that. I probably should make them a little more circular.
Is this the thing that was on the bottom of our worksheet the other day?
Yes, those were like really drew that. Still not great, but these are actually, I think, the easiest things to graph. You know how far out it's going to go based on the number in front, and you know where the maximum is going to be. Guys, it's always a 2 theta in there also, okay? So it's some number that you can probably take the square root of, sine or cosine 2 theta. That's a lemniscate. And I won't ask you to graph these over, like, weird intervals.
How is that the square root of sine of 2 theta? It's like it's r squared equals.
Right. So, okay, we could plug, if you want to plug a value in, let's plug in, let's do like pi over 4. We'll actually plug it in so you can see it. So r squared equals 16 times the sine of 2 times pi over 4. Okay, so r squared equals 16 times 1. Positive and negative, right? Yeah. Yeah, it'll be sine or cosine. It'll always be 2 theta. That's it with lemniscates. Yeah, that's it. That's all it has. So guys, try to do r squared equals 16 cosine 2 theta. You guys try to graph that. And you don't have to show work on this if you're like, I know where that's going to be. Great. Put it there. I'm fine with that. So think about cosine. Because when you see the r squared, you're like, okay, I know this is a lemniscate. Kind of like if you saw in the format of a limousin, you're like, oh, that's the shape of a cardioid. Like, we're not going to plot every point to get to that, but that's what it would look like if we plotted all the different values. So you can just use that and go, I know what this is, and draw it. Okay.
Oh, yeah, I don't even realize I see it anymore. Like, I leave it.
Oh, for cosine, no, for sine, yes.
So for sine, you start at the pole, right?
Yeah.
And go like that. For cosine, do you
Start out
here?
there and go.
Do you go this way or just
Yeah.
that?
Should go positive.
Oh, okay.
You get the sucks.
Yeah. Let me see this. Oh, that? Yeah. Okay. They should be the same size. Mine kind of aren't, but that's okay. Questions? Are lemniscates the easiest thing we've graphed? Well, maybe circles were easier. But...
No, I think lines. I think lines.
Lines, maybe. All right, guys, turn the page.
No, there are more.
2 more lemniscates. Here we go.
We'll have to do it.
Yeah, try.
Okay, that's it.
Wait, so the sine starts here?
What is it?
Yeah.
Don't ask questions.
Like that's where, yeah.
Isn't that positive?
Yeah.
Thank you.
Yep.
Don't bash on my biscuit on.
I apologize to your lemon biscuit.
Why is it
I took some risks and I graphed a bunch of
Some
Is
risks.
that correct?
Nailed it.
Let's go!
We're just gonna put this in the movie and give them I literally write these fancy ass things for it, and I put it in like just like simplistic terms. So
Like little eyes, you know, like.
Okay, it has 4 weeks of mental.
Oh,
Here.
What's the entire circle? Oh.
We're gonna make it. Nothing too exciting. My kiddo's gonna play with a neighbor friend and just fun little get together. Oh, last night he had his end of season hockey party, and it was at this place called Ultimate Archery. It's basically dodgeball with archery.
wait, I want to play.
I'd like, they're like these. Oh my gosh, it was amazing. So fun. It's kind of like, they're like flat on the ends, kind of like giant darts that you're shooting at each other, you know? And you wear like a face mask, but they don't like
So
hurt.
it's like paintball with like actual.
That'd be so.
They have like barriers and things set up, and you run around.
I don't want to.
It's like, wait,
Highly recommend. Ultimate Archery.
it's the wait. If every single one of us gets a star on this military, will you let us do that with you?
Ooh, yeah, can we have Reflection Day at Ultimate Archery?
Yes.
Exactly.
Be entertaining. All right, guys, these two. Yay?
Yay.
Yay.
Yay. We can graph lemniscates, right? Okay. Woo. You got it, Ethan? Okay. All right. We are not doing all of these, okay? So let me... We're doing some of them, but not all. Let me pick and choose. Let's look at... For 2 here.
I should remember they existed.
And guys, I'm going to show you... You don't need your calculator for this. I just want to show you what's happening and what we're actually solving. Because it's a little weird to look at that and go, what, I'm solving that? Like, what do you want to be? You have a decent amount of math in your future. The MCAT, yeah.
See, what if I'm trying to
The MCAT is called.
marketing into graphic design?
You will not do that.
Yeah, I will be doing
You can
anything.
make great crafts though, right?
Right, I make like pretty I make pretty colors. I put them together and choose one, and I do that for people. That's it.
No, guys, just pay attention up here. I'm doing. So guys, I'm changing. Hey guys, up here. I'm changing this to graph simultaneously instead of sequential. Normally your graph graphs one and then it graphs the other one and then like however many you put in. I'm putting it in simultaneous because when you're solving this, you're not just looking for like, oh, if I have a line and a circle, where do they intersect? You're looking, do they intersect at the same time almost, if that makes sense? Like as you're traveling around the circle and you're going through the line, did they like meet at the same? Yeah, it's a weird way to think about it. So let me make sure. We'll try this and see if my like interval was good enough.
Whoa.
That was not quick enough. Let me see.
In my opinion, I think that was good. You haven't done that?
Bro, I never do these like secrets. They have like
Oh, what?
Okay, let's see. I also want.
Yo no sé.
Okay. I know I'm doing lots of things that you're like, what is happening? Okay, watch one more time. Let's see. Okay, so now do you see it drawing it? I know it's slow, but that's so we can pay attention.
How are you doing this?
It is. The other one's coming.
I'm really surprised it shows up.
This doesn't seem to be sequential, does it?
This is
It didn't like it.
Oh,
Wow.
That doesn't sound it's back.
It seems more sequential.
Is this why you all just was Harry Potter this year for Halloween?
Right.
You're wizards.
Because we're wizards. That is why I don't have you graph lines over intervals, because it's weird. Because if you plug them in, it's like this section and then this section and then this. It's very straight. That's why if we're graphing a line, we just graph a line.
I don't understand anything that's happening.
Oh, it is still set up. I never actually clicked simultaneous. Sorry, guys. One more viewing, okay? Ready? Ready? Oh, there they go together. Okay, they intersected there.
Wait. Oh. Oh my god.
There you go. Okay. Yeah, it's like, did it go in the corner? Woo! Yeah. Okay, so do you see how it intersected twice? Okay, so we now get to algebraically find those two solutions.
Sports betting. Oh, yeah, 100 days.
You know what we should do is to like during one of our reflection days. There's this thing where you get groups of people and they all put like an initial of their name on the board and to guess where the people are going to pass to.
Oh, yeah, the little screensaver thing. Yeah.
Yeah.
I like it. All right, guys. We are solving 0 to 2 pi, and that's what I set the window to graph on the calculator. Like, it stopped at 2 pi. So what's your instinct for how I might solve this system of equations? Set them equal to each other, right? They're both equal to r. So couldn't I do 2 equals secant of theta? Okay.
Oh.
That's the same as cosine of theta is equal to 1/2, right? If your brain wants to do that. So from 0 to 2 pi, where does it happen?
Pi over 3 is 1. Pi over 3 is 1. Dude, they're never
Wait, what?
You got
Yeah.
Oh my god.
Okay. So think back to algebra land. When you solved systems and you gave your answers, did you just tell me like x equals? No. How did you give answers? Like if you had a line and a parabola. And yeah, you gave actual like ordered pairs, right? So we're going to give r theta ordered pairs. Well, what is the r? 2, right? We know that. So I've got the points 2 pi over 3 and 2 5 pi over 3. How does your answer?
Wait, how do those do it, sir?
Look at the very first part of the problem. What does it say?
Oh, just kidding.
No, that's okay. It's given to you. So
I was just kidding.
that's good. Yeah.
Just in case. Are you?
Yeah, just in case, like,
What? I am recording.
Oh, that's literally. Can we only record our class? So it's really
I usually-
Rose videos. And I'm sorry, whoever.
Oh,
class it is,
so
y'all
that
are
was from
boring.
like a year or 2 ago.
Oh, okay.
Because I
It was literally
wasn't
months ago.
planning to be out, like, so that was like
It
last
was
year's
so
video.
boring.
You guys are much more animated.
Yeah, we're more.
It really should be. I think I should seek out sponsorship.
Raid Shadow Legends.
And
How do you get how
so ordered pairs, like you're used to rectangular where you had an xy, right? In polar, we have an r theta. What's r in this problem? And then you found your theta. So 2 theta to the other theta. Okay. You what? Hey guys, quiet down. I'm having trouble hearing the question.
But how do you, if they're both equal to R, can you please give an R to and I think
What?
No, the theta is the pi thirds. Because secant of theta is r.
right.
Yeah, you see it? Okay.
I would love to.
All right, let's look at another one. Okay, guys, I'm going to have you try to solve number 4, and then we'll look at the graph and see, do you have the right number of solutions? I skipped it. That was just me writing things to answer the question, so no, we skipped number 1. All right, so try number 4.
Are you sure?
Oh, okay.
Yeah.
There we go. We're going somewhere. Hold on. Wait. Plus minus. Oh, it's just so cool. Am I doing this?
Oh, man, what? I'm at the same point. Yo, now what?
What point are you at?
Sine squared theta.
Okay.
Wait, is it not plus minus root 2 over 2 equals sine theta? Or am I?
Yeah, so when you square root that, guys, what does that become? Okay. Guys, I'm going to start typing this in on the calculator so we can have our...
So what is like the X value?
So how would you find that in algebra? Like if you found X, how would you find Y?
wait.
Oh.
What's the way? Wait.
Yeah.
If it's plus
That's
or
1
minus-
half
Plus
squared.
minus, so it's just everything inside. It's like
Isn't it
it's literally everything inside the circle.
No, it's all the
No, all the pi over 4s. Like,
Oh, that's so
So then how do we have to rate like a bunch of points then too?
Yeah.
Oh, that's so fun. Okay.
Oh, is it one half?
I over 4.
What's this? Cumulative. That's what's in there. And the cumulative.
This is a
So this is pi over
Because you need to do something.
I kind of forgot that the cumulative is like
I think.
If we decide to do it over 2 days, guys, we'll get the calendar updated so you'll know. Like, I'll put an announcement out too because I know you want to know if it's.
Please call 911.
If you decide to make it 2 days, it'd be like the 17th, not the 13th, right?
Right.
Yeah, but it's very.
So, like, if we do it 2 days, it'd probably be the 15th and 17th.
Oh.
I wouldn't just be like, okay, 2 days, so no review. Have fun.
That'd be so funny.
That'd be awful.
Yeah, chilling for a couple of days.
Which is? Yeah.
It's literally everything.
Yeah. But you see, I'm not. Oh, wait, I'm just dumb.
Just because put it apart on the data.
No, I'm still dumb. What? It's not fruit too.
What's the next?
Then, oh, there's a fruit too.
Limits and, what do we do next?
We've done it. I went from not knowing how to use a given
To knowing.
I still don't sign that.
Exactly what I was.
I moved it.
All right, guys, should we watch the calculator? Are we ready? Start counting.
Oh,
1, 2.
3.
Oh, hold on. I need to change.
4.
I know. I didn't put this thing on. Okay, now we'll be able to
Wait,
see.
what does that do?
It shows that there's like a dot.
Oh, like how it's changed.
Yeah. Okay.
Oh,
1.
oh.
It got slower too.
I think it's because it's
2.
Oh, wait, it's speeding up. It's like the Flash.
3. 4. All right, guys, did you get 4 answers?
Yes.
Did we get, okay, let's check our signs here. Root 2 pi over 4. Root 2, 3 pi over 4. Negative root 2. Did we have the negative, guys? Yeah. All right. Okay, think back algebraically. If you knew x, how would you find y? Plug it in. So, if I plug in pi over 4, what do I get? If I plug in 3 pi over 4, what do I get? So you plug your thetas back in. Okay? How long do I have? Till 9:09. Okay. I'm so off today on time.
Are we done?
Is that the end of them? Oh, no, those were there. Oh, let's, baby, hold on. All right, guys, let's just go to your homework. So you have time to get it done, so maybe you don't actually have.
Or maybe.
Oh, it's on.
We're not gonna do those right now. Yeah. Right now. Well, we might do like number 5 as more like
I do not know.
that is. You're never gonna do that.
Oh,
Yeah.
Not doing.
Wait, what about number 1? Like, how will we
Yeah.
do we just plug in?
Yeah, you just plug it. Then I can show you everything.
But then it'd be like, our equals 2 plus the spiral 3D sign is like, it's like the square root of 3 over here. So then it'd be
I think for this
2 square root times square root of 3. So then it'd be r equals square root plus 2 times square root of 3.
yeah, like you agreed to be like -2 over 4 sine of -4.
Well, what is it?
Yo, I love doing that. Oh my god, I would do that every bit. I love when that happens.
So you guys just like bring them in. Yeah.
Hold on, what is this? How good is it? 10 long. No, then the radius of each feet is so how is it root 10 long? No.
Well, root 10 is close to what? It's a little more than 3. Yeah. Okay. Okay, on the homework, you're graphing all of those on the front.
Oh yeah, you're right.
Close to what? Try again. What's the square root of 9, which is close to 10? Okay. So just over 3.
So what you're doing, that works without. Yeah.
Oh, yo.
They added the hamburgers on Netflix.
Yeah.
I'm a little late on figuring this out.
Okay.
So I got to this point, like trying to say it goes plus or minus 3.
Okay. Where does that happen?
At 5 4 3 7. I got that part.
All right. So then to get the R value, because it doesn't just say R equals a number. Like this.
Yeah, it's the original.
So you plug it into either one. I think that's easier to plug it into.
So I was like 5
This
4.
one, you said that the coefficients would be square rootable.
Well, what's 10 like? What's that close to? Okay.
Oh yeah, so it's 0 to pi here.
2 sine.
What's the sine of pi over
Oh,
4?
this is a spiral.
Root 2 over 2.
Times 2.
It's root 2. Which is what I got, but like,
So, and then you just do that for each one of these.
and why is it 2 negative?
So if you're in the 3rd and 4th quadrant, is it sine negative?
So
What if we had, like during our lovely 2 week reflection period, what if we had like a movie day? And we all got popcorn and stuff and we just watched a movie. I know kids would probably now,
Cosine's negative in the 2nd and 4th, right?
Cosine? 2nd and 3rd.
That's what I meant, sorry.
Yeah.
That's what
Yeah.
I'm saying. So, sine of theta equals this, right?
No, theta, like,
Sorry, theta equals this, but,
so you find theta first, then you plug that in to get your R values. You can plug it into either equation.
it will be 0.
oh, I thought you always have to do that, like, draw the bar.
We're not graphing.
Oh, so you find theta.
Solve for theta.
huh? This is how I remember things.
And guys, I'm gonna have you skip one on the back, but let me decide which one.
Okay. So yeah, you find theta and I got, that's what I got, but I was confused on how to get the R, and so I got R equals this, but then you multiply by 2, so, okay, so you get root 2.
Perfect.
I don't even get lunch.
3.4 times 2 is 4.8 plus 2 is 6.
I'm so confused.
But could we do an artistic reflection? Because we all know we're definitely not reflecting. Love the confidence.
What is this?
Yeah.
Literally my words.
But I'm not. Yeah.
After we do
Hold on.
Let me look for it.
I was like, is it though?
Wait, no, that's not how this works. So what do you got? 8.6 for.
So the 8 and 7 only.
How we do would be 3.2. 5.2.
Hey guys, on the back, let's skip number 6. That's a weird one because you're graphing a circle and a 4-petaled rose, which is a lot to think about. So
But will it be a lot for the
Wait,
you'll be okay.
for which bat? Oh, for the packet one?
No, your homework. Number 6 on the homework.
So R equals sine theta and R equals 2 sine 2 theta?
Yeah, skip that one, okay?
Oh, that one was so weird.
What? Really?
How do you do this?
So you get your value when you plug in theta, take it times 2 and do